Are you someone who wants to learn hypothesis testing? If yes, this video will help you. Hi, I am Ira Masila Canaria. I am a third-year student of Eduardo L. Hoson Memorial College under Bachelor of Secondary Education major in Mathematics. In this video, I'll be discussing about one sample z-test and Pearson product moment correlation coefficient or Pearson R. So what are you waiting for? Let's start! Let us first define what hypothesis, hypothesis testing, null hypothesis, and alternative hypothesis are. A hypothesis is an educated guess about something in the world around you. Hypothesis testing is a statistic is a way for you to test the results of a survey or experiment to see if you have meaningful results. So we have null hypothesis. Null hypothesis is a statement about the population that either is believed to be true or is used to put forth an argument unless it can be shown to be incorrect beyond a reasonable doubt. On the other hand, we have alternative hypothesis. It is a claim about the population that is contradictory to the null hypothesis and what we conclude when we reject the null hypothesis. Null hypothesis, denoted as H sub O, is always have an equal sign, while alternative hypothesis, which is denoted as H sub A, does not have an equal sign. Now, let's proceed to my screen for hypothesis testing. One sample z-test. The one sample z-test is used to test whether the mean of a population is greater than, less than, or not equal to a specific value. The z-test assumes that the population standard deviation is known. Z-test is used when n or the sample size is greater than or equal to 30. Let's have an example. A mathematics teacher claims that the average time of solving 3 problem-solving questions is 15 minutes with a standard deviation of 3 minutes. To test the teacher's claim, a random sample of 30 students took 3 problem-solving questions and have a mean of 13.5 minutes. Is there sufficient evidence to support the teacher's claim? Test at 0.05. In hypothesis testing, we have 7 steps to follow. First, formulate the null and alternative hypothesis. Second, decide the level of significance. Third, choose the appropriate test statistic. Fourth, establish the critical region. Fifth, compute the value of the statistical test. Sixth is the decision making. And the last is draw conclusion. So let's start with the first step. Formulate the null and the alternative hypothesis. We have here our null hypothesis. Which is mu is equal to 15, or the average time of solving 3 problem-solving questions is 15 minutes. And our alternative hypothesis is mu is less than 15, the average time of solving 3 problem-solving questions is less than 15 minutes. Less than because it shows here that 13.5 minutes is the mean of the sample, which is less than 15 minutes. Let's go to the second step. Decide the level of significance. So the alpha here is given, which is 0.05. Now to the third step. Choose the appropriate test statistics. So we will use one-tailed left directional test because we use less than in our alternative hypothesis. To our fourth step, we will establish the critical region. So since we use one-tailed left with the alpha of 0.05, we will use negative 1.64, seen on the table. In our fifth step, compute the value of the statistical test. So we will use now the Microsoft Excel. So as you can see, we have here all the data that we are collected from the sample of 30 students. So to compute the z-com, we will go to the data, click the data analysis, and choose the z-test for 2 sample means. So that's why we have here a dummy column. So click OK. For the input, select the first column, which are the data, the minutes taken of 30 students. And for the variable to range, select our dummy column. So for the hypothesis means difference, select 15. So for the variable 1, variance, since we have standard deviation of 3, we will use 9. And for the variable 2, we will use 0.0001 nearer to 0 because we will not use 0 here. So click the labels. For the output range, select where you want to put the result of the test. So click OK. So now we have here the result. So delete the dummy because we don't need this. So we will expand this. So now we have here the ZCOM negative 2.738613. We can use this for our decision making and also the p-value here. In the decision making, we will reject the null hypothesis if ZCOM is less than or equal to the Z-tab. So we have here negative 2.73 is less than or equal to negative 1.64. So we will reject the null hypothesis. So using the p-value approach, we will also reject the null hypothesis because 0.003 is less than or equal to 0.05, which is our level of significance. So now, for the last step, we will draw the conclusion. Since we reject the null hypothesis, there is no sufficient evidence to support the teacher's claim. Therefore, the average time of solving 3 problem-solving questions is less than 15 minutes. So now, let's have here the Pearson product moment correlation coefficient or Pearson R. We are using this type of test to know if there is a relationship between the two variables. So we have 3 degrees of relationship, the perfect correlation, which in positive R is equal to 1, in negative R is equal to negative 1. And is the sum degree of correlation, which in positive R is greater than 0 but less than 1, and in negative R is greater than negative 1 but less than 0. And the last one is the no correlation, which is R is equal to 0. Here is the formula for the Pearson R, where x is an independent variable, y is the dependent variable, n is the sample size, and r is the degree of relationship. So now, let's have an example. A researcher wants to find if there is a significant relationship between mathematics anxiety and mathematics competency of 15 grade 10 students of PC and HS. The researcher will use the scores of the grade 10 student in mathematics anxiety test and mathematics competency test 0.05 level of significance. So first, we will formulate the null and the alternative hypothesis. Our null hypothesis is P is equal to 0. There is no significant relationship between the mathematics anxiety and mathematics competency of the grade 10 students of PC and HS. And for the alternative hypothesis, P is not equal to 0. There is a significant relationship between the mathematics anxiety and the mathematics competency of the grade 10 students of PC and HS. So we will use Microsoft Excel. So we have here the data from the 15 students of grade 10 from PC and HS. So to get the value of R, type equals correl and select for the array1 the first column, comma, and select for the array2 the second column, and then enter. So we will get negative 0.88659, which is highly negative correlation. We said that it is highly negative. This means that when a student has high level of math anxiety, he has a tendency to get a low score. To compute the p-value that we will use in decision making, click data analysis, and choose the regression. Click OK. So for the input 1 range, click the first column and drag. So for the input 2, click the second column, drag all the data there. So click the labels, and for the confidence level, click it. Since we have 0.05 alpha, so our confidence level is 95%. So for the output range, click where you want to put the result or the summary of the test. So click OK, and now we have here the result. So now that we have the result, we can see from the T statistic that it is negative 6.63985. So we will also use the negative here, which is equal to our R earlier. So to test the hypothesis, we will use the p-value, which is 0.00000239. Now, let's proceed to the decision making. So we will reject the null hypothesis if p-value is less than or equal to alpha. In the Microsoft Excel, we get 0.00002, which is less than or equal to 0.05. The conclusion, since we reject the null hypothesis, there is a significant relationship between the mathematics anxiety and the mathematics competency of the grade 10 students of PCNHS. And that's for today. Thank you and God bless.